Good morning, everyone. I'm Kishan Shinde, pursuing my engineering in Sri Venkateswara College of Engineering in the domain of computer science with artificial intelligence. So today's topic is hidden Markov model, which we might call as HMM. So come, let's dive deep into the topic. Introduction. Hidden Markov model is a statistical model that is used to describe the probabilistic relationship between a sequence of observations and a sequence of hidden states. It is often used in situations where the underlying system or process that generates observation is unknown or hidden. Hence, it is got as hidden Markov model. It is used to predict future observations of classified sequence based on the underlying hidden process that generates the data. An HMM consists of two types of variable, hidden states and observations. Hidden states are underlying variables that generates the observed data, but they are not directly observable. Observations are the variables that are measured and observed. Let's take an instance or a problem statement and dive more about this model. Let's see how it works. So let's take an problem statements which we might say as predicting the weather of next day based on the current day's weather using HMM model. So first we need to import NumPy, Matplotlib, and Seaborn and HMM library of course. So for importing NumPy, we import it as NP and Matplotlib as PLT and Seaborn as SNS and HMM learn as HMM. So now let's define the model parameters. In this example, the state space is defined as a state which is a list of two possible weather conditions, sunny and rainy. The observation space is defined as observations which is a list of two possible observations, dry and wet. The number of hidden states and the number of observations are defined as constants. So let's see here. State states we have given as sunny and rainy, and end states we are given as the length of states. So here the number of length or which is here is 2 would be given as 2 in end states. So we print this end states and observations we are made by dry and wet. So here the length of that is given as 2 and we print it. So the output would be given as hidden number of hidden states as 2 and number of observations are 2. The start probability, transition probability, and emissions probability are defined as arrays. The start probabilities represents the probability of starting in each of the hidden states. The transition probability represents the probability of transitioning from one hidden state to another, and the emission probability represents the probability of observing each of the outputs given in a hidden state. The initial state distribution is defined as a state probability, which is an array of probabilities that represent the probability of first state being sunny and or rainy, and the state transition probabilities are defined as transition probability, which is 2 into 2, that is 2 cross 2 array or a matrix, we can call it as 2 cross 2 matrix, representing a probability of transition from one state to another. The observations, the observation likelihoods are defined as emission of probability, which is again an 2 cross 2 matrix or an array, representing a probability of generating each observations from the each state. So let's see the code of this. Here we define an initial state distribution stating the state probability as np.array where it stores in an array format where zero point 0.6 and zero point 0.4 is being given, and we print this state probabilities. And transition probabilities as given as np array where zero point 0.7, zero point 0.3, zero point 0.3 and zero point 0.7 is being given and it is printed as transition probabilities. And emission probabilities are given as np.array where zero point 0.9, zero point 0.1 and zero point 0.2 and zero point 0.8 is being given, and this is known as emission probability and we have printed it here. So right side you can see the output of all these probabilities where state transition emission probabilities are being given. So creating an instance for an HMM model and setting the model parameters. The HMM model is defined as using the HMM, a categorical HMM class where HMM learn library is being used. An instance of categorical HMM class is created with a number of hidden states set in hidden states, and the parameters of the model is being using by the start problem and transmit underscore and the emission prob underscore attributes to the state probabilities and transition probabilities and the emission probabilities respectively. So here in the code we can see that we take a variable as a model where we given the categorical HMM which is equal to n states. So here model start problem is given as state probability, transition probability and emission probability is being given as a model state problem, transmit problem and emission problem here. So define the observation sequence. And sequence of observations is defined as a one-dimensional NP array. So the observed data is defined as an observational sequence, which is the sequence of integers representing the corresponding observation in an observation list. So observation sequence is equals to np.array where observations is being given and it is reshaped into -1 and 1 and it is given in the output here. So predicting the most likely sequence of hidden states. The most likely sequence of hidden states is computed using predicting method of HMM model. The hidden states model after we a model is being built, we need to predict it for the further test cases. So here we predict based on its observation sequence. So most likely hidden states is being printed as hidden states here. So most likely hidden states are 0 1 1 1 0 0. Decoding the observation sequence. The Verbi algorithm is used to calculate the most likely sequence of hidden states that generates the observations using the decode method of the model. The method returns a long probability of the likely sequence of hidden states and the sequence of the hidden state itself. So here we take the long probability hidden states and we decode the problem here using an algorithm called Vertebri. So, and we print the log probability and most likely hidden states, and the output has been given there with log probability and most likelihood hidden states. So now we need to print these results using Matplotlib. So and we use a Seaborn also here where SNS is set into a style called white grid and we plot hidden states where hidden state is being given and minus O is being given label is given as an hidden state and x variable is being given as time step and y variable is given as most likely hidden state. Title is being given as rainy or sunny. So the legend or the is being given and plot dot show is that the output is being printed in the same. So here you could see rainy or sunny. So it is given as 1% or one most likelihood that is an highest one on each step or time step that is being mentioned here. So on 0 it would be 0 and on 1 and 2 and 3 it would be 1 where it would be maximum and 4 and 5 would be again 0. So thank you. This was the small information that I wanted to share with you guys. Hope you would understand the today's topic that is HMM model. So do like, share and subscribe. See you in the next one. Bye.